I am Ennemcien, Q-Master, modulation. First question, what is amplitude modulation? Why is it necessary? I have discussed it in a posting, but I shall give the answer. Amplitude modulation is a process by which amplitude of a high frequency wave called carrier wave is changed in accordance with the frequency of a low frequency wave called modulating signal or baseband signal. Second part of the question, why is it necessary? Modulation is necessary. First point, modulation is necessary because 1. If the low frequency baseband signal is transmitted without modulating, broadcasting stations could not be distinguished from one another. Second point, antenna, A-N-T-E-N-N-A, antenna would have to be extremely large in size, of the order of wavelength of the low frequency baseband signal. So these are the two reasons behind modulating. Second question, an audio signal 15 sine 2 pi into 1500 T amplitude modulates a carrier 60 sine 2 pi into 1 lakh T. 1. Calculate the modulation factor and percentage modulation. 2. What are the frequencies of the audio signal and carrier? 3. Frequencies contained in the modulated wave. This is the question. The baseband signal is given to be 15 sine 2 pi 1500 T. Carrier wave is given to be 60 sine pi into 1 lakh T. A modulation index is the amplitude of the modulating signal divided by amplitude of the carrier, okay, or audio amplitude by carrier amplitude. That means here audio amplitude is 15 and carrier amplitude is 60. So modulation factor M equals small letter m equals 15 by 60, that is 0.25. Percentage modulation you get by multiplying small m with 100. So modulation, percentage modulation, capital M equals m into 100, that is 0.25 into 100 or 25%. Now next part is what are the frequencies of the audio signal and carrier frequency? Frequency of the carrier is 1500 Hertz. Frequency of the modulating signal or audio signal, here Fs equals 1500 Hertz. Frequency of the carrier is 1 lakh Hertz or 10 raised to 5 Hertz. The next part is what are the frequencies contained in the audio signal? Frequencies contained in the audio wave. You know that the frequencies are Fc sidebands, upper sideband Fc plus Fs and Fc minus Fs. So frequencies contained are 1 lakh Hertz, that is Fc, then Fc plus Fs, 1 lakh plus 1500, this is the answer, and the lower sideband is FC minus FS. That is 98500 hertz. That is the answer. Another one. A 75 kilo megahertz carrier. A 75 megahertz carrier having an amplitude of 50 volts, 50 volts, is modulated by a 3 kilohertz audio signal having an amplitude of 20 volts. 1. Find the modulation factor and percentage modulation. 2. Frequencies in the modulated wave. 3. Equations of the carrier and modulating waves. Now here, amplitude of the signal wave audio is 20 volts. These are given. Amplitude of the carrier is 50 volts. Carrier frequency FC is 75 megahertz. Fs, that of the audio signal, is 3 kilohertz. 3 kilohertz means 3 into 10 raised to 3 hertz. We can convert it into megahertz by dividing this by 1000 or 0.003 megahertz. You make the units of both the same. Then modulation factor M equals A by B, that is 20 by 50 or 0.4. Therefore, percentage modulation M equals 0.4 into 100, 40%. Then frequency is contained in the modulated wave. 1. FC itself, that is 75 megahertz. The other is 75 plus FC plus Fs. 75 plus, this is in megahertz, is also in megahertz. 75 plus 0.003, that is 75.003 megahertz. Third is 75 minus 0.003, that is 74.997 megahertz. Then, last question is equations of the audio signal wave and carrier wave. Audio signal wave amplitude A sine 2 pi fs into t. So Vs equals A is 20 sine 2 pi into Fc is 3 into 10 raised to 3 kilohertz. 3 kilohertz means 3 into 10 raised to 3 hertz. That into t, 2 pi ft. Or Vs equals 20 sine 6000 pi t. This is the required equation. Then equation of the carrier wave is 50 sine 2 pi into 75 megahertz, that is 75 into 10 raised to 6 t, or Vc equals 50 sine 75 into 2 is 150 into mega is 10 raised to 6 pi t. These are the two equations. Another question. How many amplitude modulating AM broadcast? How many AM, capital A, capital M, amplitude modulated? How many AM broadcast stations can be accommodated in a 100 kilohertz bandwidth if the highest frequency modulating a carrier is 5 kilohertz? That's it. Now total bandwidth is given to be 100 kilohertz. This is the total bandwidth. How many stations can be accommodated to this limit, within this limit? That is the question. Now you know that bandwidth per station or per wave, modulated wave, is twice signal frequency, 2fs. So bandwidth per station is 2fs, that is 2 into fs is given to be 5. 5 kilohertz. So bandwidth per station is 2fs, that is 2 into 5 equals 10 kilohertz. So each station requires 10 kilohertz bandwidth. Total bandwidth distributed is, allotted is 100 kilohertz. That means number of stations that can be accommodated is 100 by 10 or 10 stations. That is the answer. Please subscribe and view all the postings. That will benefit you a lot. Thank you.